Hey guys, I am part1 and in this video I will talk about Apache Kafka, its mechanism and its benefits. Because of advances in collect and save data in recent decades, we are faced so many data in all industries. Analysis of this data caused prediction and detect knowledge in different sciences. Before discussing concepts of Apache Kafka, it's important to briefly introduce publish or subscribe messaging systems. In these systems, data is sent from the publisher to the subscriber using the broker. The publisher classifies the message and the receiver subscribes to receive certain classes of messages. But it's important to know how publish subscribe messaging and Apache Kafka start. Assume you create an application that needs to send monitoring information somewhere as a simple way. You write in a direct connection from your app to an app that displays your metrics on a dashboard and push metrics over that connection. After a while, you decide to analyze your metrics over a long term. You should modify your system and add new services that can receive metrics, store them, and analyze them. Gradually, based on your needs and for various purposes, you have more applications that are using those servers to get individual metrics and use them. This architecture will have so many direct connections that are even harder to trace. As a solution, you set up a broker that receives metrics from all the applications out there and provides a server to query those metrics for any system that needs them. This reduces the complexity of the architecture. So you have built a publish subscribe messaging system. Suddenly, one of your co-workers has been doing similar work with log messages. Another has been working on tracking. Finally, you and your co-workers have followed similar path. This way is certainly better than using point-to-point connections, but your company is maintaining multiple systems for queuing data, all of which have their own individual bugs and limitations. You also know there will be more use cases for messaging coming soon. Apache Kafka as a publish subscribe messaging system and distributed streaming platform proposed to solve these problems. Kafka has several components. As a first component, I introduce messages and batches. The message is a unit of data similar to a record in database. Any messages have an optional bit of metadata as a key, which is a byte array, and are used when messages are to be retained to partitions in a more controlled manner. For efficiency, batches are used in Kafka. Batch is a collection of messages from the same partition. This is a trade-off between latency and throughput. The larger the batches, the more messages that can be handled per unit of time. But the longer it takes an individual message to propagate. Producers and consumers. Producers and consumers are the other components of Kafka. Similar to publishers in publish subscribe messaging systems, producers in Kafka create new messages and consumers similar to subscribers. Subscribe to topics and read messages. It's important to know messages have a offset to consumer detect which messages has been read and doesn't miss none of messages when stop or restart. Consumers work together as part of a consumer group to consume a topic. In this way, consumers can horizontally scale to consume topics with a large number of messages. Additionally, if a single consumer fails, the remaining members of the group will read messages. A single Kafka server is called a broker. Kafka brokers are designed to operate as part of a cluster. The broker receives messages from producers, assigns offsets to them, and saves the messages on disk. Brokers also fetch messages from disk and send them to consumers. The messages are categorized to topics, and topics are broken down into a number of partitions. Topics in Kafka are similar to tables in database. Each partition can be saved on different servers. Zookeeper is a manager of cluster and brokers knows each other by Zookeeper. The controller is selected among of online brokers. After that, the controller will manage the cluster. So, why choose Kafka? Multi-producers can write messages on brokers. Second, consumers can read messages from different topics at the same time. And as a third, the Kafka is scalable, which means you can expand the cluster and the expansion can be formed while the cluster is online. And as a finally, all of these features caused high performance in Apache Kafka. As a conclusion, overview on Kafka's architecture. Zookeeper ensemble as the manager of the cluster should be set. You should use at least 3 machines and it's recommended use the odd number of machines. After that, set the brokers and create connections among them by Zookeeper. The controller will be elected among online brokers by Zookeeper. And finally, producers and consumers should be set and connect to Zookeeper and brokers. Congratulations, you have a Kafka cluster. thanks for your attention. For any question, you can contact me by my email.